Good morning, grade 5. How are you all? Today's date is 30th of April. The day is Thursday, and you're going to complete a unit more about electricity. How do changes affect electrical circuits? This is the part 2 of it. This is on pupils book page 115 and 117. So let's start. The learning outcomes that are going to be there is the same. Predict and test the effects of making changes to the circuits, including the changes in the number and the type of electrical components. Okay, that means you're going to keep on changing the number and type of electrical components, and we're going to see how it affects the circuits. So let's review. What did we see the last experiment? When we tried to add more bulbs in an electrical circuit having one battery, the bulbs will not shine brightly because they will have less electric current flowing through them. But if we add a number of batteries, the bulbs will shine, so they will have more electric current in the circuit. So today I want to ask you, before I continue the lesson, do you think that it's going to be the same for the motors and the buzzers? Instead of lamps, if we will add the motor and buzzer, do you think it's going to happen the same? So let's start. We have used 1.5 volt battery and we're using the same program of circuit builder because we can't be doing this experiment in the lab. So we're going to do it here on simulation, in which we can add our wires, we can add as many as buzzers and switches. So what do you think the buzzer and motor does? A motor is used to run electricity to turn around and round. For your hair dryers, for your machines that go in circles, motors are used there. Whereas buzzer, they're used to make sound. Okay, we have connected our circuit using a switch and all the wires and lamp starts lighting up, right? Like how we have learned before. Now what does a motor do? As I told before, the motor, when we turn the switch, we close the switch, the motor starts rotating, it goes round, it goes in circles. This motor is used in almost everything in your toys which needs to be rotating, like in your car wheels. It has a motor. It has motors in your blenders, hair dryers, because you need air to produce. Now let's see what the buzzer does. The buzzer makes a buzzing sound. It makes a sound, and when we increase the battery, the sound becomes louder. And same is the case for the motor. When you put the motor, it will move faster. Let's go for the next circuit builder. In this next circuit builder, you're going to change something. We are going to use the same pattern, but we are going to try to put more electrical components with same 1.5 volt battery. Okay, so we have put a motor, we have put a buzzer, and I'm going to remove one wire, and I'm going to add another wire to complete a circuit here, and then a bulb to complete the circuit. Do you think it's going to run? Everything is going to work on 1.5 volt battery. Electric energy is enough? No. Only the motor is going to work, and that also very, very slowly, because all these three things need electrical current to flow through, but they're not getting enough electrical current for it to work. So if we will remove one of the bulb, and we'll complete the circuit with the wire, and now if I close, yes, the buzzer starts to work. One electrical component is less, so there is more electrical energy flowing in the same circuit. Now if I change the battery more, you can see the motor also starts moving faster, and the buzzer also starts making more noise. It becomes louder. And if I will remove the wire and I'll add the bulb inside, what do you think will happen? All of them work, because the 3 volt battery has more power, more source of electricity, it is going to allow more energy to pass through. But in 1.5, again, it's the same case. not enough electrical energy to pass through, and it will not work. All the electrical components will not work. I remove the motor, but still you see the buzzer is only working, not the lamp. And if I remove the lamp, remove the lamp and put it down, and I complete the circuit, is it complete? No. I need a 3-volt battery. I need some wires. Yes, and then I close the switch. It starts working because more electrical energy is there. 3 volt is giving more electrical energy. Let's change it with the motor again. Let's remove the buzzer and put 2 motors. Let's see what happens then. And we put the 1 volt 0.5. Both of them are moving. You see, both the motors are moving at 1.5 and at 3 volt they start moving faster because more electrical current, more source of electricity. Do you think this is going to be the same for the buzzer also, like how it was for the lamp? Now I'm again changing the battery to 1.5. I'm putting 2 buzzers inside. Close the switch. Let's see how does it work. No, because not enough energy for the buzzers to work. But when you put it to 3 volt, yes, enough energy for the buzzers to work. That's good. So everybody understands this thing. If we have more electrical energy passing through, it's going to work more. The electrical components are going to work more effectively. But if the source of electricity, the battery, is less, then less electrical energy is going to be flowing through it, and we won't be able to have all the components working.
The larger the diameter of a wire, the lower its resistance will be. And this is because the charge carriers, which make up the current, have got more paths along which to flow if the diameter is bigger. Compared to a small diameter wire, there's only a few paths that the charge carriers can flow down. Another way to look at this is just like a motorway versus a normal small road. You can fit a lot of cars per second flowing down this motorway compared to this smaller road. And so this is like the large diameter wire compared to a small diameter wire. We can fit an awful lot more traffic, if you like, or charge carriers down the larger diameter wire. So let's put that into words. The larger the diameter of a wire, the lower its resistance will be. This is because ... the charge carriers, and in this case for a wire it will be electrons, the charge carriers have more paths along which to travel. They have more paths. That's the key word here. What about if you make the wire longer? The longer the length of a wire, then the greater the wire's resistance will be. Now, why is that? To understand this, we need to take a look at what's going on inside a wire, a metal wire. Now, a metal wire, the structure of metal is a lattice of positive ions, positive metal ions, in a sea of freely moving electrons, or what we call delocalized electrons. That's a good phrase to remember. A lattice of positive metal ions in a sea of delocalized electrons. Now these positive metal ions cannot move. They are the atoms. They're held in place. but these electrons are buzzing around like little pinballs, bouncing into the atoms, bouncing off, and when a current flows, it's like you apply a pressure to one side of the wire, that's the battery, and that makes these electrons drift to the right, and a current will flow. They're still bouncing backwards and forwards, but they're drifting on average to the right. So every time they collide with an ion, the electrons can lose some energy. So the energy they've been given by the battery, as they travel through a resistor or resistance wire, they will lose some of that energy, and it will be given off as heat or vibration of the ions. So if we made the wire longer, then there will be more collisions of these electrons with the ions, and so they will lose more energy. And that's why increasing the length of a piece of wire will increase its resistance. So let's put that into words. So this is because ... there will be more collisions with the metal ions. There will be more collisions with the metal ions by the flowing electrons, let's put, by the flowing electrons, and they will lose more energy. Okay, the larger the diameter of a wire, the lower its resistance, but the longer the length of a wire, the greater its resistance, because there'll be more collisions. There's double the length, you've got double the amount of collisions.
Now I want you to open your pupils book, page number 117, and question number 1. Will bulbs A and B be brighter or dimmer without bulb C in the electrical circuit? Will the electrical current in the circuit be smaller or larger? So there are 3 bulbs connected together, and they're asking you, if you will remove one, will the other 2 start shining brightly, and the electrical current after removing them is going to become smaller or larger? Think. Grade 5. Think. So let's look at the question, at this circuit. It's drawn in the same pattern as we have it in our book on page 117. 3 lamps, lamp A, B and C. They're all connected. And when we close the switch, the electrons are passing through them. It is flowing from the negative part to the positive. You can see all of them are working. But are they shining bright? All 3 of them are shining brightly. What if I cut one? I open the switch. Yes, I made a mistake. I should have. Yes, and then I should remove the bulb and then connect the wires. What do you think will happen now? Yes, the 2 bulbs, lamp A and lamp B, will be shining more bright. That's very good, grade 5. So what's the answer going to be? The answer for question number 1. What is it going to be? 1A. Well, it's going to shine brighter and the circuit is going to have less electric current, smaller electric current, or larger? Bulb A and bulb B will be shining brighter without bulb C in the electrical circuit. The electrical current will be larger without bulb C. You're correct. Now let's go forward. Now question number 1b is, will the bulbs A, B and C be brighter or dimmer if the similar battery is added in series to the electrical circuits? We had two batteries, right, earlier in this, and will the electrical current in the battery be smaller? We had two batteries having the three lamps A, B and C. If I will open the switch and I'll cut the wire and add another battery, what do you think is going to happen? I'm not doing a circuit diagram using the symbols. I'm showing you with the real electrical components. Yes, when I will add a battery more, the bulbs are going to start shining more brightly. Bulb A, bulb B, bulb C will all shine brightly if another battery is added in series to the circuit. Well done, great. Because it's going to shine more brightly, more electrical current will flow through. So the electrical current will be larger in the circuit. That's an excellent observation. Then let's continue with question number 2. An electrical circuit containing a bulb, battery and switch are connected in a series. The table shows electrical current flowing through the circuit when different copper wires are connected in series to the circuit, one at a time. The wires are of the same time and length, but the different thickness. There are three wires, okay? If they are connected, they were used in the same circuit, and the measurement was taken. The electrical current was taken in amperes. That's the unit of current, okay? For X wire it was 3 amperes, for Y it was 5, for Z it was 8. Okay? Now looking at this, you have to tell me in question number 2a, which wire X, Y or Z is the thickest? Explain your answer. Which wire X, Y or Z is the thickest? Explain your answer. You can look into the table again. Wire X, Y and Z, electrical current in A in amperes. We call it as amperes as scientists. I'll show you the three wires. The wire Z, because the thicker wire is there. That's very good, grade 5. Thick wire allows electrical current to flow through in an electrical circuit more than the thin wires. You're correct. Very good. Now I want you to continue with question number 2b again. Will the electrical current in the electrical circuit be smaller or larger than 5 ampere if a shorter wire of the same type was used in place of wire Y? You know wire Y, it was having 5 amperes, right? It was a medium sized wire. What do you think if we have the same type of wire Y, but you're taking some different sizes? That means one is long and one is short, like this one. One is a short one and one is a long one. What difference do you see in both of them? Will the electric current be the same, or is it going to be different? Looking at the picture, this is the same wire, only the length is different. It is the same wire Y. What has happened, grade 5? Think. The electrical current will be larger than 5 because the shorter wires allow larger electrical current to flow there than the longer wires. You can see in the first one, the first picture shows a shorter wire. That is what they're asking. If we will use a shorter wire of Y, and we will see which will that electrical current be more in that circuit or in the other one. In the shorter wire, it's going to be more because the electrons can pass through it very easily. There's more paths of the electrical current, right? Very good. I hope you understood the topic, and now I want you to copy and paste the following link to learn the study set. This is the same one that I had given to you earlier. This is for those students who have not done it till now. Do it. It's going to be very helpful for you to understand electricity better, and I want you to revise it once again. And Ramadan Kareem to all of you. I hope you have a great day ahead, and take care of your family and yourself, and stay safe and stay at home. Have a blessed Ramadan. Goodbye.